In this next example, we're going to layer on the finding of not only the horizontal asymptotes, but also the vertical asymptotes. So we're going to remind ourselves how to do that. And another thing we're adding to this is, well, now we have a square root involved. So how do we deal with that? So what we need to kind of think about is when we're deciding what the highest power of x is in the numerator and the denominator, we need to keep in mind that we have x squared inside of a square root. So even though I can't take the square root of each of these terms, that's an algebraic no-no. I have to think of the highest power of x as being x to the first power, because in a way it's kind of like these x squareds are being kind of undone by the square root, by the raising to the 1/2 power. Which means when I do this limit and use the strategy we've been talking about, I need to make sure to multiply top and bottom by 1 over the highest power of x, which effectively speaking is x. So 1 over x on the top and the bottom. But I'm going to make a little adjustment. I'll multiply by 1 over x on the bottom, but since I have the square root on the top, I'm going to multiply the top by square root of 1 over x squared, which is going to evaluate to the same thing as 1 over x. Since we're thinking about x going to positive infinity, there's no issues with taking powers of negative numbers or anything crazy like that. So, what next? Well, if we simplify this, we have limit as x approaches infinity of square root of 2x squared plus 1 times the 1 over x squared. They both have square root symbols, so I can, and they're being multiplied, so I can bring the 1 over x squared inside and multiply it by the whole quantity 2x squared plus 1. And that's going to be all over, well, this is a familiar one. I can just multiply 1 over x to each of these terms, and I'll get 1 minus 3 over x. Okay, so continuing with this, I'm going to have limit as x approaches infinity of, well, now I'm just multiplying on the inside here. So I'll make sure to distribute to each term, and I will have on the numerator square root of 2 plus 1 over x squared, and that'll all be over 1 minus 3 over x. Okay, so recall that square root of x is continuous on its domain. And so because we have continuous functions here in this limit, we can pretend that we're moving the limit inside of the square root and moving it to numerator and denominator. In other words, we're using several limit laws at once to evaluate this limit. We're also going to use the fact that we talked about earlier, which is that we know what the limits of things of the form 1 over x to the r, where r is a positive rational number, we know that those limits are going to be 0. That tells us our final answer is going to be square root of 2 plus 0 over 1 minus 0, which equals just square root of 2. And so since we're doing this to figure out the horizontal asymptotes, just as we did in the previous example, we have that our horizontal asymptote is the equation y equals square root of 2. All right, now we're not done with the problem because it also asks us to find the vertical asymptotes. So let's use previous knowledge to try to figure out how to do that. What we're going to need to remember is what is the situation that creates a vertical asymptote. We have a vertical asymptote when the function is growing without bound. Either the y values are approaching positive infinity or they're approaching negative infinity as the x value is approaching a specific number. So we take a look at this function and we ask ourselves, what is a point, an x value, that will create a denominator of 0? Turns out that x equals 3 is a quote-unquote bad point. So we use that as a potential candidate for a vertical asymptote. We have to calculate then the limit as x approaches 3 from the left and from the right of this function. And we're supposed to get positive infinity or negative infinity. If by doing one of these limits we get either of the infinities, then we're done. We don't have to do the other one. So let's do limit as x approaches 3 from the left, and if that's good enough, then that's good enough. So limit as x approaches 3 from the left of square root of 2x squared plus 1 over x minus 3. Okay. So how do I do something like this? We don't have that this function is continuous at 3, so I can't just plug in 3 the way I did with a lot of these other problems after doing a little bit of algebra. I have to remind myself how to do this type of limit. So what we're going to do is we're going to do a little side calculation and think about what limit as x approaches 3 from the left of 1 over x minus 3 is. And the way we're going to figure this out is thinking about what numbers get closer and closer to 3 from the left. So I have 2.99, I have 2.999, 2.999999. When I calculate what 1 over x minus 3 is for each of these, I'm going to get big numbers. These are going to be big negative numbers. If you don't believe me, try typing this into your calculator. Try typing 1 over 2.99 minus 3, 1 over 2.999 minus 3, 1 over 2.999999 minus 3, and see what you get. In each case, you're going to get big negative numbers, which means the closer and closer we get to 3 from the left, the bigger a negative number 1 over x minus 3 is. It's going to be as big of a negative number as we want, which means this limit is negative infinity. Okay, we have, going back to the limit we were trying to calculate, we have a numerator that is continuous as x approaches 3 from the left. So we know that the numerator will tend toward just a regular number. The denominator is tending toward 0, but from the left. In other words, 1 over x minus 3 is approaching negative infinity. So if I have a numerator that's tending to some finite number that happens to be positive, and I'm multiplying that by something that is going to have a limit of negative infinity. In other words, what I'm thinking is splitting these up, rewriting this algebraically in the following way. We know that the square root part is going to approach some finite number, in this case a finite positive number, and we know that 1 over x minus 3 is approaching negative infinity. So what we conclude is if I have a finite positive number being multiplied by something that's negative and getting more and more negative, then the overall result is negative infinity. And what we talked about when we talked about vertical asymptotes is if any of limit as x approaches a, limit as x approaches a from the left, limit as x approaches a from the right, gives infinity or negative infinity, then there is a vertical asymptote. At x equals a. Okay, so what that means is our suspicion that x equals 3 was a vertical asymptote was actually correct.